Alright guys, the answer to number 7 is 2. The answer to number 8 is infinity. The answer to number 11 is 5. The answer to number 12 is 4. The answer to 15A is 0. B is 1. C is infinity. 16A is 0. B is negative 2/3. C is negative infinity. 19 is 2/3. 20 is 1/3. 21 is 0. 22 is 4. 23 is negative infinity. And 24 is negative infinity. It is out of 16 points. So that one will be out of 16 points. All right. When we are doing limits at infinity, what we are finding is if the end behavior of a function. So when you find the limit as x approaches infinity, so that means when you go all the way to the right, you're telling me what that y value is. For example, in number 7, we said our limit was 2. So what you're saying is x goes to infinity, y is going to 2. If we would do the limit as x goes to negative infinity, and we would maybe get y equals 2, that tells us the end behavior of what is happening at our function. If the limits approach the same value, you have a horizontal asymptote there. For example, on number 7, if both of our answers, as we did the limit to infinity and the limit to negative infinity, if we got 2 both times, that would be a horizontal asymptote at y equals 2. So if we read page 193, it just reiterates what I said. So at the top of page 193, there's a little box, and it says the line y equals L is a horizontal asymptote if your limit as x goes to negative infinity is L, and if your limit as x goes to positive infinity is L. So it's saying if your limit as x goes to infinity and x goes to negative infinity is the same thing, you have a horizontal asymptote at that value. So recall, how do we know where a vertical asymptote is? If you think about it, we knew where a vertical asymptote was by looking at the denominator in an equation and saying when it was undefined. Sometimes we got a hole there, but we won't worry about that just yet. We'll figure those out a little bit later. Right now, we're only going to worry about asymptotes. So we're going to look at our homework problems that we just graded, and we're going to see if we would find the limit as x approaches negative infinity, is it the same answer that we got prior? If it is, we're going to label it as a horizontal asymptote. If it's not, we're just going to say there's not one. We're also going to find vertical asymptotes, critical numbers, y-intercepts, and x-intercepts. So let's get started. On number 7, we got a limit at x, as x approached infinity, of 2. So if we would put negative infinity in here, so we would have 4 plus 3 over negative infinity, divided by 2 minus 1 over negative infinity. 3 divided by negative infinity is still getting close to 0. So you're still going to have 4 over 1 divided by negative infinity is still getting close to 0. So 4 over 2, which is 2. So we're going to state that we have a horizontal asymptote at y equals 2. For our vertical asymptote, we're going to look at our denominator of the original equation. Here's our original equation. So if we look at its denominator, what makes it 0? So 0 equals 2x minus 1. So x equals a half. You solve for x. That is our vertical asymptote. To find critical numbers, I'm not going to go through that because I believe that you guys are good at finding critical numbers. You should be able to find a critical number by finding the derivative and setting it equal to 0. The y-intercept, we might need a little refresher here. The y-intercept, we put in 0 for x. So I'm going to go 4 times 0 plus 3 divided by 2 times 0 minus 1. If you solve, you get negative 3 for a y-intercept. For an x-intercept, you do it a little bit different. You put in 0 for y. So we got 0 equals 4x plus 3 over 2x minus 1. If I multiply, I get 0 equals 4x plus 3. If I solve for x, I get negative 3/4. Come with questions next time if you do not know how to find an x and a y-intercept, and if you do not remember how to do the vertical asymptote. Also for horizontal. All right. Problem number 8. We said our limit was infinity. That's not a number. So I can tell already that this is going to have no horizontal asymptote. Because that is not, you can't have a horizontal asymptote at y equals infinity. Not possible. So vertical asymptote, we look at our denominator again. You should say x equals negative 1. For your intercept, y-intercept, plug in 0 for x. So you get 0. Plug in 0 for y. This one I'm going to actually write out because you have to show a little bit more work here. We are going to cross multiply and get 0 equals 2x squared. So x would be 0 as well. So here are our answers. Besides the critical numbers, which we're going to find the derivative and set equal to 0, and we all know how to do that. All right. So number 11, we got 5 when we put in infinity. Well, if you put in negative infinity, guess what you get? 5. So we have a horizontal asymptote at y equals 5. Vertical asymptote, what makes our denominator 0? Nothing, because you have squared plus 1, so there is no vertical because it will never get back to 0. I'm not going to go through the x and y intercepts because I believe you guys can do those as well. I'm going to breeze right through the rest of these. If you have questions, come see me. So I would stop the video, see if you can get the same answers, come with questions for next time. All right, number 12, I would say a horizontal asymptote at y equals 4 because I would plug in negative infinity. I would not get a vertical asymptote because you can never make that 0. For 15, I would get a horizontal asymptote at y equals 0, and I would get a vertical asymptote at x equals 1. For B, I would get a horizontal asymptote at y equals 1, because that's what I got for my limit, and I would say my vertical asymptote, some of you are going to screw this up, I would say x equals 1, that's all some of you are going to say, but then I would say x equals negative 1, so watch that. There is no horizontal asymptote because that's going to infinity. Our vertical asymptote is at x equals 1. For 16, we have a horizontal asymptote at y equals 0. We have a vertical asymptote. This one's tricky because you had to add 1, you had to divide by 3, and then uncube. So I'd say the cube root of 1/3. For B, we have a horizontal asymptote at y equals negative 2/3. And we have a vertical asymptote at x equals 1/3. And I would say no horizontal on number C, letter C, not number C. I would say my vertical asymptote is also at x equals 1/3. For 19, I would say horizontal at y equals 2/3. I would say a vertical at x equals negative 2/3. For 20, horizontal at y equals 1/3. Vertical, yikes, not possible. All right, 21, horizontal at y equals 0, and vertical at x equals 1 and x equals negative 1. 22, horizontal at y equals 4. I'd say vertical at x equals 0. For 23, no horizontal because we can't have negative infinity one. I would say our vertical is at x equals negative 3. For the last one, I would say no horizontal, and I would say my vertical is at x equals 0. Yay, go you. Come with questions for next time.